Hello, Ms. Rush. This is my engineering project, the makeshift fan portfolio. Um, in the table of contents, page 3, I've got the problem statement and so on and so forth. For the problem statement, in this challenge, the problem was to make an energy converter out of household items. And for this challenge, I chose to convert electrical energy into mechanical energy using a battery pack and a motor and a fan. So with this type of energy conversion in this industry, fans are mainly used to cool components of a machine down, and they do that by like displacing heat to also help cool objects. The type of energy conversion that my fan mechanism displays is inexhaustible. It's an inexhaustible wind energy generation caused by the transfer of energy from electrical to mechanical. In the past, fans have not always been powered by electrical motors. Some people used to manually fan objects, and once motors were invented, motorized fans became much more commonly sold to people in their houses. A very common way to see a fan is the ceiling fan or a house fan or fans as a part of a machine to cool something down. So for the research, one of the three companies I chose was Dyson. Dyson was created in 1991 by Sir James Dyson of England. This company has a very, very large operation that sells more than just fans. They also sell vacuum cleaners and other home appliances. Dyson creates and consumes a lot of energy as it requires a power source to use a fan, but with the amount of fans they sell, they also generate a lot of energy. The next company I chose to research was DeWalt. DeWalt is another company that produces electrical to mechanical conversions. They do this by selling power tools. These power tools are used by people for home improvement and various other projects. This company and their products produce tremendous amounts of energy as their operation is extremely large and popular with families at home, along with companies that need tools. The third and final company I chose to research was Tesla. Tesla is a company that produces electric cars that use batteries to then convert from electrical energy to mechanical energy when they move. So the batteries power the wheels and the wheels turn, which is mechanical energy. This company has an extremely large operation as their cars are very popular. Because of this, the company produces a lot of energy with the amount of batteries that people use and when they charge them and how much they drive. So during my brainstorm process, the reason I chose to use a battery pack was because it was a very simple way to get electric energy, and then I just thought anything with a motor is a good way to demonstrate electric to mechanical energy conversion. And so as you can see, I thought about a battery powered remote to an RC car, a battery powered just straight motor, and then my final idea was the battery powered fan. The reason I chose this is because I thought it was the most effective way to demonstrate um, the conversion of energy from electrical to mechanical, and also it was one of the most commonly used functional ways. Now, during building, the main struggles were attaching the wiring and taking apart the pre-existing fan that blade is attached to. Other than that, it was not that bad of a process creating this. It was just a little tedious, but afterwards it was successful. And so here is the video of the fan working. And so here's me showing the parts of it. Below it is the motor. And so when I turn it on, it spins. Now that is one of the flaws. It could be spinning faster to generate more wind. And so that brings me to the next part of my project, which is the evaluation. Now, the prototype I designed performed above my initial thoughts and standards. I didn't think it would spin as fast as it would, as the battery pack was very robust using two double D batteries, but overall it was still a little slow. Could have been better if I had used both a bigger fan blade and a more powerful energy source. And another issue was that I didn't build a stand for it, so it couldn't operate without me holding it, and it would commonly get caught in its own wires and disconnect itself. So for the final conclusions, my prototype was very successful. It transferred energy efficiently from electric to mechanical through the battery pack into the motor, then spinning the fan. However, my design could have been improved by building a stand for the fan so I didn't have to hold it. I could have hidden the wires better so it wouldn't get caught in the blades as much. But other than those flaws, the only other thing I really could have improved was the source of power, which I didn't have the resources to do. So looking it all over, I thought it was a very successful project. So thank you. Have a good day.